Good day, guys. This is Mr. Prince Maths and Science class, and in this video I'm going to be solving some word problems on Venn diagrams. The first example says, in a class of students, 12 like maths, 8 like science, and 5 like both. It says how many like either maths or science. So now we are looking for students who like just one subject. So let's represent number of students who like math to be n m okay, and number, let me put it hash of students, number of students who like science will be ns. Okay, so now nm is equals to 12 and ns is equals to 8 to 8. Number of students that like science is 8. Okay, and it says the number that like both, that will be n m intersection s is 5, the number of students that like both. So if we want to know the number of students that like just one of the subjects, because they said 12 like math, 8 like science, and 5 like both. So if we have to get this number of students that like just one subject, that will be number of students who like maths plus the number of students who like science minus the number of students who like both. Okay, because we're just looking for a number of students who just like just one subject. So that will be 12 plus 8 minus 5. So our final answer will be 15. Okay, so that's it for that question. So the next question says, let A and B be two finite sets such that number of A is equal to 20, number of B equal to 28, and number of the A union B equals 36. So the combination of the two sets is 36. So now we have to find the set that is common between A and B. Okay, so I'm going to draw the Venn diagram. So this is like the Venn diagram. Sorry, let me make it a little bigger. So now we have A and B. Okay, and the number of A union B, that's the total, is equals to 36. Okay, so we say number of A is 20, number of B is 28, and we have to look for this one. This will be X. This is what we are looking for. And in the first video I did, I gave the formula to find the number of A union B, and the formula to find A of the union of two sets is the number of A plus the number of B minus the number of of the set of what is common between both sets. So then this is the one we are looking for, right? So if we made this our subject of formula, we have that n A intersection B is equals to n number of A plus number of B minus number of A union B. Okay, so so the number of A is 20, number of B is 28. Okay, and A union B is 36. So 20 minus 28 is 48. So we have 48 minus 36. So the answer is 12. So X is equals to 12. That's A intersection B. The number of A intersection B is equals to 12. Okay, so that's it for that question right there. So now let's do number 3. Number 3 says, if n, the number of A minus B, is equals 18, and the number of A union B is equals 70, and n is equal a number of a intersection b equals 25. It says then find b. So we are still going to use the same formula, but first of all I'm going to draw the Venn diagram. Okay, let me draw the Venn diagram. So if we draw the two sets A and B, and the number of A union B is equals to 70. Okay, so we know that what is common between A and B is 25, so this place will be 25. Okay, and then it says the number of set that is A that is not in B is that was represented as n into of number of A minus B is equals to 18. Okay, so now what we do now, let's write the formula. So now to find A, to find, well, we have to find this, the number of B, right? So the A minus B is 18. This is 18. This part is 18. All this part is what is 18. What is in A but is not in B is 18. Okay, that's what this part represents. That's what this part represents in the question. So from the formula we have above, n number of A union B is equals to n into A minus B plus n into A intersection B plus n into B minus A. So A union B is 70, so we have 70 is equals to A number of A minus B is 18. The number of A of what is common between A and B, that's A intersection B, is 25, and plus n B minus A. Okay, so if we do that one, 70 is equals to 18 plus 25 is 43 plus n into B minus A. So n into B minus A is equals to 70 minus 43. That will give us 27. Okay, so now we have to find B, but we only know n into B minus A. So the formula that we can use to get B, the number of sets in B, will be n into A intersection B plus number of B minus A. Okay, so that will be 25 plus 27. So 25 plus 27 is 52. So that's it. So therefore the number of B is equals to 52. So that's it for that question. So let me go to the next question. The next question says, in a group of 60 people, 27 like cold drinks and 42 like hot drinks, and each person likes at least one of the two drinks. So it says how many like both coffee and tea. Okay, so now let A is equals to set of people who like cold drinks, and let B is equals to set of people who like hot drinks. So the total is 60, right? So we know that the number of A union B is equals to 60. 27 like cold drinks, that the number of A is equal to 27, and the number of people, set of people like hot, the number of B is equals to 42. Okay, so now we want to find what is common between A and B. So if we want to find what is common between A and B, it's still going to be the same formula of n into A union B equals to number of A plus number of B minus A intersection B. So but now let's just make number of A intersection B the subject of formula. So in that case the formula will be like this: number of A plus number of B minus number of A union B. Okay, so number of A, the number of A will be 27, and the number of B is 42. So the number of A union B is 60. Okay, so we have 69 minus 60, which is 9. So therefore we can say that 9 people liked both tea and coffee. Okay, so then we'll say number of A intersection B is equals to 9. Therefore 9 people like both tea and coffee. And sorry, I forgot to draw the Venn diagram. So the Venn diagram is supposed to look like this. A, B, and the number of A union B is the total of the people is 60. Okay, and this says number of A is 27, number of B is 42. So we have to find this place X. So since we got that place is going to be 9. X is 9. So the next question says there are 35 students in art class and 57 students in dance class. It says find the number of students who are either in art class or in dance class. It says the first question says when 2 classes meet at different hours and 12 students are enrolled in both activities, and it says you find those when 2 classes meet at the same hour. So first of all, I will draw the Venn diagram. Okay, so now let's say let NA represent students in art class. Okay, and let a number of D represents students in dance class. Okay, so now let's draw the Venn diagram. So this is it. We have A, we have D. Okay, so number of A is 35. 35 students are in arts class and 57 are in dance class, and we have to find both students who are both in dance and arts class together. So that's what we are looking for. So and then we have that A intersection D. In the first question, it says when 2 classes meet at different hours and 12 students are enrolled in both activities. So for both activities, that's A intersection D, that's 12. So this side is 12. Sorry, this side is 12. Okay, 1, 2. Okay, so now number of students in our class is 35. Number of students in that class is 57, and A intersection D is 12. Okay, so now the first question says when 2 classes meet at different hours. When 2 classes meet at different hours. So that will be number of A union D is equals to number of A plus number of D minus the number of students that are common to both classes. So we already know that the number of A is 35 plus 57 minus 12. Okay, so that's 92 minus 12. 92 minus 12 is 80. Okay, so this is the number of students. This is when the 2 classes meet at different hours. This is the number of students that are enrolled in both activities. So now the second question says when 2 classes meet at the same hour. So in this case we are still looking for A intersection D2. but in a different way. So this A intersection D is going to, in this case, is going to be an empty set combined with A union D. Alright, so in this case the formula we're using is number of A plus number of D minus number of A intersection D. Okay, so for this case, we say when two classes are the same, this is what it connotes. This is what it connotes. Okay, but that's not that. But that's what it connotes. But that's not how we're going to do it. I just did that as an illustration. So for the two classes that meet at the same hour, it's just basically going to be addition of A and D. The number of students in art class, the number of students in dance class. That's just what the question is asking for. So in this case, the number of A intersection D will be equal to number of A plus number of D. Okay, so number of students enrolled in art class is 35, and the number of students enrolled in dance class is 57. So that will be equals to 92. Okay, so that's it for that question. So now, in this case, now we are going to do a question that involves 3 sets. It's going to be a question that involves 3 sets. This is the next question. Question that involves 3 sets, and this question says, in a school we have a total of 50 students. 25 like science, 20 like English, 12 like math and science, 10 like math and English, 8 like science and English, 5 like all 3 subjects. So now the first question says, how many students like only math? So the first one we do, we'll write out all the parameters we have. So we have number of students that like math is 28, right? Number of students who like math is 28. Number of students who like science is 25. Number of students who like English is 20. Number of students who like maths and science is 12. Okay, number of students who like maths and English is 10, and the number of students who like science and English is 8, and the number who like all 3 is 5. Okay, and the total number of all the students, and the total number of students M union S union E is equals to 50. So now I'm going to draw the Venn diagram here. I will draw the Venn diagram below. So this is what we have here. Okay, we have math, science and English. So the number of students who like all 3, the total number of students, is 50, and the number of students who like math is 28. Number of students who like science is 25. Number of students who like English is 20. Number of students who like science and English is 8. This is where it's going to be written. Number of students who like math and English is going to be 10. Number of students who like maths and science will be 12. And the number of students who like all 3 is 5. Okay, so now we have to look for how many students like only math. So now this is what we are asked to look for. But first of all, before we can do that, we have to note those who like exactly 2 subjects, and then we can subtract from those who like all 3 subjects. Okay, so I'm going to start with part B of the question. Let me start with part B because that's the only way we can get part A of the question. So for those who like only maths and science, this is how we denote it. It will be number of M intersection S intersection E prime. Okay, so this is what we are looking for. This is what we are looking for. So if we are to look for the one that like, this is for what, when students that like only math and science. So that will be that will be the formula will be number of students who like math and science minus the total number of students who like all three. Okay, which is M intersection S intersection E. Okay, so in this case, for us to get number of M intersection S intersection E prime, M intersection S is 12, and the total of students like all three is 5. So that's 12 minus 5. So that will be 7. Okay. So now let's do for number of students that like only math and English. Only maths and English. So for only maths and English is going to be number of students who like maths and science. Sorry, who like maths and English minus number of students who like maths all three. Okay. So for maths and English, that's 10. So that will be 10 minus 5. Okay, so that will be 5. These are the number of students now that like only maths and English. So for number of students that like only maths and science, only science and English, my bad, only science and English, that will be number of students who like science and English minus number of students who like maths, science and English. So when this is the formula you always use whenever you have to find whenever you are given like 3 sets, and then you have to find number of students who like just two parts of the set only. So what you do, you take the two that are in consideration, and then you take the number of students who like both two, the both two you are looking for, minus the number of students who like all three. So that's the same formula that I use for everything. That's why you see me using the same formula. I'm always subtracting from M intersection S intersection E. So that will be 8 minus 5, and 8 minus 5 is 3. So we have to do, therefore, the total number of students. We have to find the total number of students who like just exactly two subjects. Total number of students who like exactly 2 subjects. It will be equals to 7 plus 5 plus 3. So that will be 15. Okay. So now that is for A. So that's for B, sorry. So now let's do A. Number of students. This is number of students who like number of students who like only math. So for only math, the notation, the set notation, the symbol, this is the symbol. It will be number of M intersection S intersection E, both prime, because this is the only one that we are looking for that like only maths. Okay, so we are looking for students that like only maths. So that will be number of students who like maths. Okay, minus, it will be minus the number of students that like maths intersection S prime intersection E. Okay, intersection E plus number of M intersection S intersection E prime plus number of M intersection S intersection E. Okay, so the number of students who like math is 28. Okay, and the number of students that like only maths and English is 7. Okay, the number of students who like only maths and science is 5, and the number of students who like all three is also 5, So that will be 28 minus 7. 5 plus 5 is 10, plus 7 is 17. So 28 minus 17, that's 11. Okay, so that's it for number of students who like only maths. So if we want to do the number of students who like only science, it will be number of mass intersection S intersection E. This will be both prime. Okay, so it's still going to be the same thing. So the number of students who like science minus the addition of the number of students who like only maths, only maths and science. Okay, plus number of students who like only science and English. Okay, plus the number of students who like only would like all three. Sorry. So in this case, the number of students who like science is 25. Okay, and the number of students who like only maths and science is 7. Number of students who like only maths and English is 3. And then all three. So number of students who like all three is 5. So that will be 7 plus 3 is 10, plus 5 is 15. So we have 25 minus 15. So that will be equals to 10. Okay. So now, if we want to do the number of students who like only English, So only English will be number of M intersection S intersection E. This one we have prime. M prime intersection X prime intersection E. So that will be number of students who like English minus the total number of students who like maths, who only like science and English, plus number of students who only like maths, maths and English. So if it's only maths and English, that will be M intersection S prime intersection E. Okay, plus number of M intersection S intersection E. Okay, sorry, let me write it here. Plus N intersection M intersection S intersection E is equals to 20 minus into 5 plus 3 plus 5. Okay, so that will be 20 minus 13. So that's 7. Okay, so now let's find now the last question. Let me scroll up to see the last question. It says the number of who like none of the subjects. So now that will be M union S union E prime. So number of students who do not like any of the subjects. So that will be the total of all the students minus all the number of students of what is inside the circles. So now we have to find number of M union S union E all prime. Okay, so and to get that will be the number of M union S union E minus total of sets inside the circle of set inside the circles. Okay, is equals to 50 minus 11. So now let's put all the things inside the circles, even plus the ones that we found, plus the one who are like exactly 2 subjects, plus one who like only 1 subject. We're going to add up everything and then subtract from the total number of students. So that'll be 50 minus 11 plus 10 plus 7 plus 7 plus 5 plus 3 plus 5. Okay, so if we add up all this inside the bracket, that will be 48. So that'll be 50 minus 48. So the number of students who like none of the subjects is 2. Okay, just 2 students. Sorry.